In this lesson, we're going to continue looking at graphing equations. In this lesson, we're going to be graphing equations that are given in standard form. Remember, standard form is ax plus by equals c. And in order to graph these equations, we want to convert them so that they are in slope-intercept form. And once they're in slope-intercept form, we can then graph it like we did in our previous lesson. To do this, remember, you have to solve the equation for y. The steps to doing that are 1, add or subtract the ax term. So that's going to be this term here. You want to add or subtract whatever the opposite is to move it to the other side. Then, step 2 is to divide all terms by b. So that's going to be this term here in front of the y. By following these two steps, your equation will be in slope-intercept form, and then from there, you'll be able to graph it. So let's practice simply just converting from standard to slope-intercept form. Number 1. First, we want to start by moving this x term to the right side of our equation by doing the opposite. So instead of x, we're going to subtract x from both sides. X minus x is 0, so that can cancel out. And on the left, we are only left with y equals. I can't subtract negative 2 minus x because they're not like terms. So I'm just going to simply bring everything down. As I bring it down, I'm going to put my x term first, negative x, then my constant, minus 2, so that it's in slope-intercept form. Our second step is to divide by b. But if you notice here, there's nothing to divide by. So I am done. This is our equation in slope-intercept form. Number 2, negative 4x plus y equals 5. So again, we're going to start by moving our ax term to the right. In order to move negative 4x, we need to add 4x to both sides. Notice how I am not placing the plus 4x underneath the 5 because again, I can't add those two. Negative 4x plus 4x equals 0, so that'll cancel out. And all I have left on the left side is y equals 4x plus 5. Because again, I can't add those two terms and I want it to be in standard form. So I want my ax term to be first and my constant to be second. Making sure you're paying attention to whether they're positive or negative terms. Now that I have my standard form written in slope-intercept form. Let's look at one more example of reviewing converting from standard to slope-intercept form. Number 3, we're going to start by moving our ax term to the left. So we're going to move 5x. In order to move that, we're going to do the opposite, and the opposite of 5x is to subtract 5x from both sides. 5x minus 5x is 0, so we can cancel that out. And on the left, we're only left with 6y equals, again, I can't subtract those two terms, 12 and negative 5x, so we bring it down. Negative 5x plus 12. For this example, I do have a b that I need to move to the right side of our equation. So to move that, I'm going to divide all of my terms by 6, which would result in y equals negative 5/6x plus 12 divided by 6 is 2. And now that it's in standard form, or in slope-intercept form, we'll be able to graph it. Go ahead and highlight number 4, 5, and 6. Now let's look at, if you're given it in standard form, how we would graph it. Just like we did in the previous examples, we want to convert it to slope-intercept form. To convert number 8, we're going to subtract 3x from both sides, which would result in y equals negative 3x plus 5. Now that it is in slope-intercept form, I can use this form to graph it. And remember, to graph it, we start by graphing our y-intercept, our b, which in this example is a positive 5, and then our slope, m, and in this example is negative 3, just like we did in our previous lesson. To graph our y-intercept of 5, we plot the point 0, 5. So on our graph, 0, 5 is here. Then we use our slope, which needs to be written as a fraction, so we place it over 1, negative 3 over 1. And remember, to graph our slope, we rise and then run. And with a slope that has a rise of negative 3, that means we're going to go down 3. And then a run of positive 1 means we're going to go to the right 1. So starting from our existing point that we already have graphed, we're going to go down 3, right 1 to get our second point. Then we're going to go down 3, right 1 to get our third point. Once we have 3 points, we can then connect going all the way through our graph with arrows on the end to show our line. Let's look at another example. Number 9. So again, this equation is in standard form, and in order to graph it, we need it in slope-intercept form. So we're going to start by converting it and moving our ax term over by doing the opposite. So we're going to add 2x to both sides. This would result in y equals 2x minus 1. Now that it is in slope-intercept form, I can use what I've learned in my previous lesson to graph it, taking my y-intercept of negative 1 and my slope of 2 to graph it. So with a y-intercept of negative 1, I'm plotting the point 0, negative 1, which is starting at my origin down 1. Then I can graph my slope of 2, which is 2 over 1, because we need to rise and then run. Because our rise is positive, that means we're going to go up 2, and our run is positive, so we're going to go to the right 1. Starting from our existing point on the graph, we're going to go up 2, right 1. And we're going to do that twice, up 2, right 1. And once we have 3 points, we can connect our points. Let's look at one more example together. Number 10, 5x plus 2y equals 6. Again, this is in standard form, so we need to rewrite it so it's in slope-intercept form. And we'll do that by subtracting 5x from both sides. This would result in 2y equals negative 5x plus 6. But unlike the previous two examples, I have a b term in front of my y that I need to move to the right. So in order to move the 2, we're going to divide everything by 2. This results in y equals negative 5 over 2x plus 3, because 6 divided by 2 is 3. Now that it is in slope-intercept form, I can use this form to graph it. So I can take my y-intercept of 3 and my slope of negative 5 over 2 and graph it. Because my y-intercept is 3, my point would be 0, 3. So on my y-axis, I'll go up to 3. And then with a slope of negative 5 over 2, That means I'm going to go down 5 and to the right 2. So from my existing point, down 5 and to the right 2. And because of my graph, I'll only be able to graph 2 of those points, but I can connect those two to create the equation of my line. Go ahead and highlight number 11, 12, 13, and 14.